22 asks us to draw a two-circle Venn diagram. Let's get our universal set. Two circles, so we'll put two circles here. Label one S and one T, and what we want is to shade this region right here, S union T prime. Let's get an idea of where this is going to be. So the elements that are in this set are in here or in here, right? They're in S. Well, here's what S looks like. If they're in S, they're going to be in here, or, right, or they're outside of T. Now, outside of T, I'll do that in blue. Outside of T is here. Here's everything outside of T. Be careful, I want completely outside of T. Now, this set here is going to be anything that's shaded, anything that's in S, as well as outside of T. So anything that's got some shading on it, like in here, 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 that's going to be in this set right here. So I'll try to shade that in red here. It's going to be kind of a big mess here. So anything that's got shading in it, right here, looks like it's going to work. See if I can get this to work a little bit better. So anything with shading should work. So what we're left with is everything except this little moon-shaped region. Problem 23 asks us to draw a three-circle Venn diagram. So let's start by drawing our universal set. Here's three circles. We're going to have an R, a set S, and a set T. And what we want to do is we want to shade the region that's R prime, intersect S, intersect T prime. So let's just say this to ourselves and see if we can just write it by saying it. So where are we here? What about this one here? That says that we're outside of R. This one here says we're inside of S. And this one says we're outside of T. So try to get a feel for where we are. We're outside of R, right? So here's R, so we're outside of R, right? We're outside of R. But we're inside of S. So we're outside of R and in S. So we can't be here because that's in R. So we're outside of R but in S. So right now we're in this region right here. But then we also have to be outside of T. So look where we are here. Outside of, here's R. We want to be outside of R. So we've got to be outside of R. But then we also have to be in S. So that puts us in this region right here. Right? We're outside of R, but we're also in S. But then the third one says we have to be outside of T. So now, instead of all of this, we have to eliminate that. So we're going to have, how about this region? If you put any dots in there, put some dots in here. Where are those dots? They are outside of R, they're inside of S, and they're outside of T. So we're going to shade this region right here. 24, let's use De Morgan's laws to simplify this expression. So we could write, all right, S intersect T prime prime, and then what we're going to do is use De Morgan's laws, and that's going to allow us to distribute this prime, that complement. So that's going to give us this. That will give us S prime union, right? When you apply De Morgan's laws, it changes this symbol. And then we're going to have T prime prime. Well, S prime is simple. Union, now, what is T prime prime? So this is T, this is outside of T, and this is outside of the outside of T, which puts us back into T. It's like a double negative. There we go. Now, let's distribute this using De Morgan's laws. So that's going to give us S prime, prime, union, right? Because when we use De Morgan's laws, whatever sign that is, symbol that is, it changes direction. And then this will be T prime prime union S. And now we can simplify these. These are double negatives in a sense, so this is going to be S union T union S. So what we're going to do is we're going to take everything in S and combine it with everything in T, and then combine that with everything in S. Well, this is redundant here, right? You take everything in S and put everything in S together, you still just have S. So what we're going to have is this is going to simplify to S union T.